Hi and welcome back. In this video, I'll be discussing two questions on Nernst equation. Let's begin. Exercise 1. A galvanic cell consists of lead anode immersed in 1 molar solution of lead nitrate and a platinum cathode that has gaseous hydrogen bubbling over at pressure 1 atmosphere. The hydrogen ion concentration is 1.3 times 10 to the power of negative 5 molar. You are required to write the cell notation for this reaction, calculate the cell potential as well as predict the spontaneity of the reaction. Additional information given are the standard reduction potential for lead as well as the standard hydrogen electrode potential. Do recall that in order to write the cell notation, you have to follow the format of A, B and C, and from the question it is clear that lead is acting as anode, therefore hydrogen would be at cathode. Now let's look at the answers for this. Firstly, lead solid is converted into Pb2 plus aqueous. Make sure to place a straight line between them to indicate the difference in phase. The aqueous ions has a concentration, so do include that. Next would be the bridge indicated by two straight lines. Following the bridge would be the cathode. H plus ions in aqueous state are converted into hydrogen gas. The concentration of H plus ion is included as well, and the pressure of hydrogen gas is also included. Make sure to separate them with a straight line to indicate phase difference. Since the reaction requires a platform for reaction, it would be platinum as cathode. Place a straight line to differentiate the gas phase and the platinum solid phase. The next question requires you to calculate the E cell for this reaction. From the question, it is clear that the reaction is occurring at non-standard condition. Therefore, you have to use the Nernst equation to calculate E cell. That would be E cell equals to E naught cell minus 0.0592 divided by N multiplied by log concentration of products divided by concentration of reactant raised to its power. E naught cell is calculated based on the reduction potentials given. Use the formula E cathode minus E anode. Insert corresponding values and make sure to write your answer with the correct symbol and unit. Next, write the half equation and cathode. That would be anode is the oxidation of lead solid to become Pb2 plus aqueous. At cathode, it would be the reduction of hydrogen ions to become hydrogen gas. From the chemical equation, you should be able to identify the products and reactant that will be used in the Nernst equation. Do recall that only the aqueous and the gaseous state reactants or products will be used in this Nernst equation. So let's substitute in the corresponding values. E naught cell would be 0.13 minus 0.0592 divided by 2. That would be the value of N. Since the number of electron transferred is 2, multiplied by log the concentration of Pb2 plus ion, which is 1, pressure of hydrogen 1, divided by the concentration of H plus ions raised to the power of 2. Where did we get raised to the power of 2? It is the stoichiometric our overall chemical equation. So the final answer is given to be negative 0.16 volt. Make sure to include your sign as well as unit. For the final question, you are required to predict the spontaneity for this reaction. Since the E cell value is negative, therefore the reaction is non-spontaneous. You can include an explanation together because E cell value is negative. Now let's move on to the next question. Exercise 2. A galvanic cell S is made up by immersing zinc metal in X molar concentration of Zn2 plus solution and copper metal in 0.25 molar Cu2 plus solution. The two half cells are connected using a salt bridge. Given is the standard reduction potential for zinc as well as the standard reduction potential for copper. You are required to calculate the concentration of Zn2 plus ion at 25 degrees Celsius if the cell potential is given to be 1.075 volts. Now, a tip to answer this question would be when the question is asking you to calculate concentration, you should recall that you must use the Nernst equation. So the simplified Nernst equation would be E cell equals to E naught cell minus 0.0592 divided by N multiplied by log concentration of products raised to its power divided by the concentration of reactants raised to its power. Now let's look at how to answer this question. Firstly, calculate the E naught cell because that is required in our Nernst equation. It would be E cathode minus E anode. Now, how do we determine which is cathode and which is anode since in the question it was not indicated? Look at the values of the reduction potential. The more positive value would be the cathode and the less positive value would be the anode. So here copper had the more positive reduction potential, so that would be our cathode, and zinc had a less positive reduction potential, so that would be our anode. See, the overall E naught cell value would be positive 1.1 volts. The next thing you should do after calculating E naught cell would be to write out the half equations happening at anode and cathode as well as the overall equation. So at anode, oxidation is taking place. That would be zinc converted into zinc 2 plus. At cathode, the reduction of Cu2 plus is happening. And the overall equation would be now, I was able to write out the overall equation straight away since the electrons on the left hand side and the electrons on the right hand side is balanced. Next, write out the Nernst equation. That would be E cell equals to E naught cell minus 0.0592 divided by N log concentration of product divided by reactant. From your overall equation, you should be able to see that only zinc 2 plus and copper 2 plus will be included in the Nernst equation since they are in aqueous phase. Substitute in the corresponding value, which would be E cell 1.075, E naught cell 1.1, and value of 2 since 2 electrons are being transferred, log concentration of zinc 2 plus, which is what we are required to calculate in this question, divided by the concentration of Cu2 plus that is given in the question. The final answer should be 1.75 molar. A quick tip to answer Nernst question is that always prepare your E naught cell value. Number 2, your half reactions, and as well as the overall equation. This is important since in the Nernst equation we require the E naught cell value, and from the half equations we are able to find out the value of N, and from the overall equation we will be able to see the products and reactants raised to their stoichiometric coefficient. Here the stoichiometric coefficient is actually 1. That's all for this video. Thank you.